Okay, so here we have to see how to use the control. Now hash is basically used to put comments into the console. So for example, the comment is adding two numbers. This is the comment that I'm typing up. So this will be included anywhere. This statement will be ignored by RStudio and I'm hitting enter. Now R can be used at the instant calculator. So for example, you can say 1 plus 1. So on the very next line, if you observe, a 2 is being reflected. You can say 2 minus 2. So 0 is being thrown as the result. You can say 3 into 3. A 9 has been thrown as the output. Or you can say 25 divided by 5. So we have got the answer as 5. So in this manner, R can be instantly used as the calculator. You can also perform the complex calculations. So for example, you can say 10 plus 1 and now you see a bracket is being solved and 12 is being added to it. It could have been a multiplication operation as well. So you can say 10 plus 2 and still it is able to respond to it. We can also use the interface as a scientific calculator using exponential values. So it also responds to the exponential values or exponential queries. So for example, if we saw over here, pi is the inbuilt function in Studio. So sine pi by 2, if we say, you can also say cos pi by 2. So pi is also the inbuilt function in R. We can also specify the absolute value. So for example, if you say minus 10, the value will be returned as 10, or absolute say minus 1 and value will be returned as 1. So absolute values can also be specified in the RStudio or in the R environment. We can also calculate square root. So for example, 225 we take, 15 is being returned as the answer. So square roots can be calculated inside the Studio. So it can directly be used as the calculator. And also there is a function called as floor. So for example, if you specify 3.16 over here, answer is being returned as 3. So these are all the ways in which we can use R as a scientific calculator or R as a calculator. So it's pretty much simple. We just have to enter the values to be operated upon. It directly performs the value and gives us the output in the result. Next, we will see how to deal with scripts in R. Now, before we close with this chapter or this part of RStudio, we just see how to get the help on math function. So you have to type question mark and after that you have to just hit math. So just write math at the console and hit enter. So you can see on the right hand side, help section is being initiated with the S4 group generic functions or S3 group generic functions. So once you click on them, you can read about the different methods, different mathematical functions being available inside the RStudio. Later on, we'll also come on to those functions, but help section also is available for your convenience to understand the functions that are available in RStudio in regards to math. Now, let's talk about vectors at a very basic level. Vectors is a data type and object in the R. It is basically a string of numbers or alphabet, but it cannot be the combination of both. Now, the power of R in case of vectors is vector can be directly used as the input to the function. So now let us see first of all what is required to create a vector, and then we have to see how to use vector inside any function as an argument or as an input to the function to make calculation on that particular vector. So now in a console in RStudio, we can create a vector, say for example num, and then we'll give the arrow and dash, and we use a function called as C, and inside C we can list the values that we wish to give to the vector. So now this is the vector with a name num, and that has got 5 values inside it, or 5 objects inside it. So this is 1 2 3 4 5, so it's just the string of numbers. This could also have been a string of text, but we'll see that later. First, let's observe how to make mathematical calculations on this created vector. So now hit enter, and you can say sum, and in the bracket we can mention the name of the vector, and we see the output. Similarly, if we want to see the standard deviation, so we can write SD and hit enter, and see the standard deviation is being created from the numbers from 1 to 5. Mean can be calculated. So for example, we can say mean, and in the bracket we can mention num. So now see, a mean is being calculated. You can also check the length of the vector. So you can say length num. Now if we see, it has got 5 elements, so a 5 number is being thrown as the output. So it says that the length of the num is 5. We can also reverse the series. Say for example, for series for num, so as soon as we hit enter, the entire series inside the num is being reversed. So it now says 5 4 3 2 1. Now in this entire series of operations, we made a use of only one vector that was named num. Now in R, we can create two vectors and perform certain operations on them, or the result of operation will also be a vector. So let's do the practical approach of it and see how does it work. So now first clear this, and say for example the first vector that we are creating will have a value num1, and C is the function that is required. So 1 comma 2 comma 3 comma 4 and comma 5, and then we have num2, and now we say again the function C is required. So now we will have some values for it. So you can say 2 comma 4 comma 5 comma 6 comma 7. So now there is num1, one vector with certain values from 1 2 3 4 5, and there is num2, a second vector that has got values 2 4 5 6 and 7. Now we can perform operations on them, and the result will also be a vector. So you can say num1 into num2. So as you can see, a multiplication resultant is available to us. This is also a vector. You can also perform division. So for example, num1 divided by num2, and the result is available to us. Again, this is the form of vector. You can say num1 minus num2 and see the output. We can also perform summation of num1 plus num2 and see the resultant as the output. So this is the way two vectors can be mathematically involved and mathematically being operated, and the result is also the vector. This was about creating and working with 1 and 2 vectors. So go ahead, create some vectors and try to experiment with them. In the next topic, we will see how to use multiple functions on the vectors. So see you in the next video. We can use multiple functions. So let us see what does that mean. So for example, if I say sum, and inside that I can say num1 plus num2. So what will happen is there will be double operation. One is num1 plus num2 and its sum calculation. So this is how we can use multiple functions and perform multiple operations. You could have also performed mean. So let's look at, so num1 plus num2 in this case. So it says 7.8 is the mean when num1 plus num2 is added. You can also do the squaring. Say for example, num1 is squared and then we are calculating its sum. So it comes out to be 55. Similarly, we can also perform standard deviation. For example, we say num1 minus 1. So this is the standard deviation after 1 is being deducted from every value that num1 consists of, and then the standard deviation is being calculated. Also, say for example, we want logarithmic value after the mean is being calculated. So that can also be done. So log and the inner function is mean. First num1 will undergo with its mean calculation and then will undergo the logarithmic calculation. This can also be reversed. For example, we can say log of num1. So a function inside the function can be integrated and then there can be multiple operations that can be performed. You can say min of num1 plus num2. So this returns the minimum value after the addition is being performed on these two vectors. You can also say a max for the same case. So you can say num1 plus num2. So the maximum value is being thrown out. This could have been a nested operation. This means we could have done like we did for mean and log. So now let's see. So we can say standard deviation, but the value of num1. So this says this is not applicable, but let's try some another example and say standard deviation of max, that will be resultant of num1 plus num2. Or if we do not want any standard deviation, we can say let's calculate the log of the value that will be max of the operation of num1 plus num2. So this is what we can do. We can go ahead and perform multiple mathematical operations using multiple functions, one inside the other, which are also called as nested functions. So you can experiment with much more things, much more numbers, and you can use much more functions like we did it here and see whether this works or not. So let's now move ahead in the next video with using vectors with a text data. So see you in the next video where we will see how to create a vector with a string of characters or alphabets. Till then, keep practicing. In this video, we have to see how to create a character vector. So for example, we say words over here. This is the name of the vector that we are assigning. And in the bracket, since this is the character data, it has to be under the quotations. So for example, we say pet, comma, bet, comma, we can say way, comma, we can say whatever you assign day. So these are the 4 elements of this vector. Now for example, if we wish to sort the data, for example, now error that is occurring over here is, it says error unexpected. So first it points out to the comma, and if I try to do it again says unexpected string constant. So this all is happening. The reason being, we have not initialized the function C, but even after initializing, still we are encountering this error. Reason is we have forget to give the comma. So we have to be very careful while we are giving any input to the vector, and this can be quite a fatal. So now if we see over here, there is no error that is being reflected, and we can use the function sort and apply it on words and see it gives the values in an alphabetical way. Similarly, if we wish to calculate how many elements or how many character does each element have, we can say nchar words, which will now count the element or characters in a one element. So for example, pet is made up of 3 characters, bet is made up of 3 characters, way is made up of 3 characters. If we make certain changes in them, so for example, if we say ways and save it, and if we now run nchar, so we see 3343. This means ways is been containing 4 characters, so it has counted it as a 4. So this is how we can create a character vector and run certain commands on it and use certain functions on it. There are more functions that are associated with characters that will come later on, but these are the 2 ways. One is the character vector, another is the numerical vector. These are the 2 types of vector basically, and if you noticed it here, they are not the combination of alphabetical and numeric. Both are need to be independent and are independent. So a vector can be either a numeric or can be a character. It cannot be a combination of both. So you can go ahead and experiment with the creating the vectors or numeric vectors and creating the character vectors and applying certain functions on it. In the next part, we will see a very crucial concept of matrices. So what are matrices, how matrices are to be created. Till the time, keep practicing the vectors. The next type of a well-known object is matrix. Matrix is the combination of a row and a column. Like vectors, matrix also can contain only one type of a data. Either it can be numeric or it can be a character data. Now let us see then how to create a matrix. So we will create 2 matrices here, and then we will see how to do matrix multiplication or functions that can be directly used on the matrix. Now think of matrix like Excel sheet data. So they also have rows and columns like Excel sheet have. So let us see how to create a matrix and then perform certain mathematical manipulations on matrix or matrices. So let's begin with the matrix and let's begin with the procedure of creating the matrix. So let's name first matrix as mat1, and then we have to use a similar function that is C, but this time let's take it as bracket inside the bracket. Now I'll tell you why, but first fill the values that have to be filled inside the matrix. So I'm making 3 by 3 matrix. That means it has to have 9 elements. So 3 into 3 is 9. So I'll include 9 elements inside it. So 5, 6, 7, 8 and 9. And I have to now define the structure. So let's define its structure. put a comma and say n row equals to 3, comma, n col equal to the 3. Now this is first matrix that is created, and it says that there is unexpected in mat1. So let's now analyze what is the error. The tricky part is there has to be a matrix function that has to be written. So now we see a matrix is created. If you type mat1, you can see, so column 1 into 1, 2 by 2 and 3 by 3, and holding the values that we have provided inside the matrix. Similarly, we can create mat2, okay, and then say matrix, and in the bracket, as we have taken bracket inside the bracket, we'll fill the same values, so 1 to 9. Alright, and then again specify the same parameters. So say n row equal to 3, comma, and col equal to the 3. We have to be bit careful. You do not have to miss out commas over here. And this has created the matrix. It says unused argument. So row spelling has gone wrong. We have to be very careful while you write the commands here. So these are the two matrix. So mat1 and mat2 are the two matrix that are being created. Now again, if you want to check, you can say mat2 here and see the matrix being created. Now these are the two matrix. So is it possible to perform some mathematical manipulation on these two matrix? For example, is there any way to perform a multiplication of mat1 with mat2, or is there any sum function that will work on mat1 or will work on mat2? So that we got to analyze and experiment with. So let's begin. So let's say sum and say mat1. So 45 is the matrix summation. So you can also calculate mean. Such is the power of R. So a mean is being calculated for matrix. A length can also be calculated. So length for what you would like to check. So let's keep it as mat1. So it returns 9. There can be a standard deviation also that can be calculated. So this is how powerful the R is. This is the amount of power that R holds, that it can directly calculate the functions over the matrices. Let's see whether matrices can be added or subtracted like we did for vectors. So let's say mat1 plus 10. Now if you observe, each value inside the matrices 1 is being added with 10. Same thing can be done with mat2. So you can say minus 10 over here. So if you observe over here, every value or every element inside the matrix is being deducted by the value 10. Now is it possible to add mat1 with mat2? Yes, this is fairly possible. If you see over here, every element of mat1 is being added to each element of mat2 and resulted into the matrix or a matrix. Similarly, multiplication can also be performed between mat1 and mat2. So here is the result of multiplication. A subtraction can also be performed. So mat1 minus mat2 is all the values were same. So 1 minus 1 has resulted into 0. So every output is 0 for this resultant. There can be division that can also be performed. So you can say mat1 divided by mat2. Obviously the answer is going to be 1 because every element of mat1 and mat2 is same. So this is about how a matrices can be created. and a matrix multiplication, division, subtraction, or certain functions on matrices can be used. Now you can go ahead and create some of your matrix with some bigger numbers and then experiment with them using the functions that we saw over here that were working with matrix. So create your own matrix and try to perform certain calculations over them. Now, before we close with the concept of matrices, there are certain more functions which are specifically designed for matrices. So for example, diagonal, which is presented here in a short form DIAG, you say mat1. So all the values on the diagonal have been reflected. Same can be used for mat2 as well. So if you see over here, so all the values on the diagonal of the matrix have been reflected. Now there is one more function which is very useful. So we can sum the rows. So you can say row sum and mention the name of the matrix. So it says the error is, so problem is with the command here. So we have to say mat1, and as we can see, the rows wise addition has happened in the matrices 1. Similarly, there is column summation option. So now if you see, there is a column wise addition of the matrices mat1. Now there is also a function that is available to combine two matrices. Let's focus on them. So one is row wise combining of the matrices, another is column wise combination of these matrices. So let's see both the function. So to combine row wise, we have to type row bind and say which are the matrices which you like to combine. So mat1 and mat2 are the required one. So here it gives the error. So to represent a row, we have to say rbind, and we have to say mat1 comma mat2. And now if we see, a combination of mat1 and mat2 but row wise is available to us. Similarly, there is an option, it's called cbind mat1 comma mat2. And now if you see, a column wise combination of matrices is appear to us. Now suppose we want to calculate a row wise means, so there is option for that too. If you look at the option here, it row means, and for which row or for which matrix you want, you can mention the name. There is also a call means option available. So this calculates the column wise means for matrix. For example, I have taken mat2 here. So this is row wise mean and column wise means calculation. So these are the functions that are associated with matrices. Go ahead, form the new matrix with higher numbers and try to do such calculation with matrix and try to use some functions with matrix. In next session, we will see how to generate the numbers. Also, we will deal with the random numbers, and also we will see what are the different packages for R that are available, how to install them and use them. Till then, keep practicing. In this part of the programming, we have to see how to generate the series of numbers, how to generate the sequence of numbers. In a real life scenario, there are many a times the situation comes when we are supposed to generate the sequence of numbers or series of numbers. Numbers can also be joined or concatenated. So we have already seen a C function that we used while we concatenating the data of a text data. So now first let us declare two vectors. So let's say and then I'd like to store some values into it. So let's store 3 values for time being, and let's create another vector b and give it the values and then store it. And now using the similar function C that I have used to create these vectors, I can combine these vectors. So as you now can see, 1, 2, 3, 4, 5, 6 has come. That means they have been concatenated. The term over here is referred to as concatenated. So C function performs concatenation. Now suppose I wish to generate the sequence of number. So let's say generate sequence of number. So there are various ways to do it. One of the easiest ways, we can make a use of a colon operator. And now if you see, a range is being generated, or series from 1 to 10 is being generated. So 1 is to 10 indicates our R to generate the series from 1 to 10. It can go backwards too. So for example, 5 to minus 5. It can be forward, it can be backwards, or you can say 1 to minus 1. So for example, so you can generate it at any range. Next is using the sequence function. In this function we have to define from what value. So for example, from 10 to that you will define up to say for 120, and what gap shall it have, what should be the difference of the numbers. So I would say 10. So if you see here, a series from 10 to 120 is generated, but the gap is being maintained of a 10 numbers. So from 10 it starts to 20, it reaches to 30, 40, 50 and so on and goes to the 120. For example, sequence can be used to generate the numbers another way too. So we can say from 25 by, and do specify the number by 3 if you say, and then specify the length that you wish to generate. So I specified 15. So 15 numbers need to be generated from 25, and the number should be at the difference of 3. So as you can notice, these are 15 numbers and at the distance of 3 have been generated. We can replicate numbers too. So for example, replicate say 10, and you have to then specify times, which is equal to 10. So 10 should be generated 10 times. This is how you can generate the repetitive numbers. Inside REP function, you can concatenate two numbers, say for example 4, 5, and now they have to be repeated. So how many times it should repeat, we have to specify say 10, and now you see a repetition has appeared for 10 times. Now for example, if I wish to generate 4, 5, this concatenated number, each, if I wish to say, so each number is being repeated 6 times. So either you can generate the combination of the numbers, or you can generate the each number the number of times you want to, or you specify. Character can also be repeated. So for example, if I say A and specify times, so you can say 10 times. So A is being created or repeated 10 times. So this is how you can generate the sequence of the numbers and characters. So go ahead, practice with more numbers, make a use of the available functions for generating the sequences, and next session we will see how to install, use the packages in R Studio, and how to download them, how to connect to the links which are required to generate or get the packages. So this will be very helpful because when we enter into the data visualization, we on and on require the packages to be installed. So it is very important to know how to install the packages and make a use of them. See you in the next session. Till the time, keep practicing. Now we have to see how to install the packages in R Studio. So now if we see at the right hand side, we have an option or a tab with the packages in here, and we can see the variety of packages that are available. If we want any package other than this, here at the corner if you see we have an option to install. So this is the direct way of installing. We have a command too. So when you click on it, and in packages, if you specify, for example, if I say ggplot, and if I will hit enter, this package will start with the installation procedure. Now this was the quick way of downloading and installing a package. We can also write the command which is written at the left. If you see in a console, it is written install.package ggplot2. So now if you see over here, it says package ggplot2 is successfully unpacked and is being sum checked. Now another way, you can directly type here install packages, and for example we want gplot, and now see a procedure for installation has begun. So this is how you can install the package. Now we'll see how to update the package or update the existing packages so they are directly automatically updated. But before that, we have to see how to put a package to the use. So the option is library, and in the bracket you have to specify that this is the package that I wish to use. Now see, attaching package gplot is being indicated to us that this package is now available for the use in here. Now let us see how to update the packages. So command is update dot packages. Now if we directly hit the enter, it will go and check each package its own update version, whether it is available or not, and will keep asking you or prompting you to update or not. So rather we'll say ask false. So we are making it disable so that it should not keep asking us for each and every package. Once you hit enter, it will go and check whether update is available for a one particular package. If it is available, it will install it without prompting any question for updatation. So over here it is automatically updating from the given CRAN or given URLs or available URLs to it. We have to say library install R. So just the final command is update R. Now if there is any update available, so it will download and update it, and now it has indicated the newer version of is available for your download. So yes, and then automatically the newest version of R will be updated and installed. So go ahead, try with some packages, try to explore certain packages, try to install certain packages. In next session, we have to see to the better aspect of R, which is data visualization. So next session, we will see how to visualize the data in R. We'll be using certain packages to create graphs, to generate graphs, to analyze data. So till then, keep practicing. See you in the next session.